Hey everyone, in this video we are going to talk about V8 evaluating expressions using properties of exponents. The unique lesson code is LRR on IXL. We are going to focus on two properties about exponents. When you divide exponents, you subtract them. When you multiply the exponential terms, you add the powers. So you're either going to add the powers or subtract the powers. So this question, let's just start with the example given in here. They're dividing 5 to the 7th by 5 to the 4th. Since we are dividing, the base is the same. 5 is the base, 7 is the exponent in here. Let me just show you the meaning of these terms. 5 is the base, and 7 is the power or exponent. Same thing applies to this 5, which is the base, and then 4 is either the power or exponent in the denominator. When you have a ratio or a fraction, the top is called numerator. The bottom of the fraction or the ratio is called denominator. So if the bases are the same, you're going to either add or subtract the exponents. That's the only things that you're going to do. So divide the powers with the same base. To divide the powers with the same base, we subtract the powers or the exponents. To multiply powers with the same base, we add the exponents. So looking at this question, I'll scroll down. Since they are dividing the same base with different powers, what we do, use the same base, okay? The base should be common, by the way, for both. Subtract the exponents. The first one, put it down and then put a minus, and then whatever the number in the denominator's power, you're going to put that number. 5 to the power of 7 minus 4. So 7 minus 4 can be simplified. It is 5 cubed. And then now you can calculate what 5 cubed equals using your calculator. That's 125. Now let's get back to the example that we have. Okay, same thing. The base is 4 in the numerator. The base is 4 in the denominator. So when we have a common base, if we are dividing, all we have to do is subtracting the second power from the first power. So you put the first power and then a minus, since I need to subtract, and then whatever the number in the denominator's exponent, you put that one. If it were to be a negative number, I would put another negative right in there. That would turn into a positive, by the way, just in case you may end up with such a question. So 4, there's only one base, I keep it, and then I simplify the power. 5 minus 2 is 3. This means 4 times 4 times 4, which equals to 64. Let's move on to the next level. Come on, okay. So the next level has a multiplication question. The base numbers are not the same, so we cannot simplify this. So let me see if I can see any easier way. No, there's no easy way for this one. We need to, because the bases are not the same. I don't think this question is appropriate for this lesson because it doesn't tell us anything about adding the powers or subtracting the powers. Once I do this, I just want to pull up the solution. I will type in a wrong answer and see why they try to figure out why they asked this question. So 6 cubed is, let's just do this first. 5 squared, I think everyone knows that this is 5 times 5 or 25. Or let's just do it step by step. But then again, this question is not supposed to be part of this assignment because it's not going to let me use the properties that I just told you. It is 5 times 5, which equals to 25. That's my second number. My first number, on the other hand, is 6 is multiplied by itself 3 times. That's what it means. 6 times 6 is 36. Times 6 is going to give you 216. And then when we multiply these together, I'm going to use my computer over here. Times 25, 5,400. That's ridiculous. I again have no idea why they asked this question. I'll just submit a random number in here and then see the solution to see if I can figure out why they asked this question. Okay, let's see. This question should not be part of this assignment because again, it doesn't let you add the powers or subtract the powers. It should be a mistake for this question to be part of this assignment. But if you end up with a question with different numbers in the base, you just calculate what they are and then multiply them. So the answer is right, but it shouldn't be part of this assignment. Okay, now let's move on to the next level, 36 point. Okay, 2 squared times 2 squared. Now the bases are the same. I can use this same base. Let me just write it in here first. 2 squared times 2 squared. If you have a common base, just keep it the same. And when you multiply, you're going to add the powers. So we have 2 and 2. Put the first one and the second one and make sure you add them together. So 2 to the power of, and at the top I have 4 because that's 2 plus 2. And 2 to the 4th power tells you to multiply the 2 by itself 4 times. It equals to 16. So some of you may be asking, like, do I need to do this like step by step? It's totally up to you. I'm not gonna check your work, but the thing is, if you just grab a calculator and type 2 squared times 2 squared and see what the answer is, you're gonna have difficult times in the long run, because algebra is based on finding some of these numbers by doing step by step instead of just punching everything in a calculator. You definitely have that option. I cannot see what you do or how you solve these questions. I have no control over it, but I would suggest doing it step by step as much as you can do it. So moving on to the next level. Okay, now this is a good example because it has a negative exponent. The base numbers are the same. Look at the base numbers. The numbers that are in the base, which are 3's. So if you have that same base for both of the expressions, you keep the base the same. Okay, and then we need to either add or subtract the exponents. So since this is multiplication, I'm going to add the first exponent and the second exponent. So I will add, let's just use another color. Okay, I'm going to add 2 of the exponents. The first exponent is 5. If you do it step by step like this, you cannot make a mistake. If not, you may end up with the wrong answer, especially when you divide them together. So now the second exponent is negative 8. I want to put it in the parentheses over here. So I would grab my calculator if I need to. Oops, that's bad. Okay, let's just put it right here. 5 plus negative 8. So I would grab my calculator if, again, I need to, only if I need to, and then see what 5 plus negative 8 equals. That's going to be negative 3. So 3 to the power of negative 3. But now look at the answer you have. It doesn't look like something that I have. It kind of like wants me to type a fraction, right? Yes, I need to type a fraction. So when this means 1 over 27, by the way. Here is how you can figure that out. You can either punch this in a calculator, that's up to you, or you can figure out how to do it. This right here, 3 to the power of negative 3, is the same as make it a fraction and then flip it. Put a 1 at the top, just like we have in here for 1 over 27. Just do it 1 over and then get rid of the negative for that exponent. Just for the exponent, just for the power. And turn that, keep that base the same, 3 to the power of not negative 3 anymore, it becomes positive 3. That's another property of exponents. If you have a negative exponent, you can flip it and then change the sign of the power. And then 3 cubed equals to 27, because it means multiply the 3 by itself 3 times. So just in case you have similar examples, I just want to put a few more examples about this negative power. You might want to pause the video and then take notes of this, because on study island you will probably need to use this property. I didn't get a chance to check the study island, but probably you're going to use it. So now here are some examples. 2 to the power of negative 5. That means 1 over 2 to the power of positive 5, or 3 to the power of negative 4. 1 over 3 in the base to the power of positive 4, or 5 to the power of negative 2. This is 1 over 5 to the power of positive 2. Let me just give you one more, a little more complicated, but I want you to see the difference. Negative 4 to the power of negative 2. So we are not changing all of the signs that we see, we are only changing the sign of the power. If it is negative, you can always do 1 over, it's negative 4, it is still negative 4 to the power of 2, positive 2. Okay, so that's the property. You can flip it, turn it into a fraction, change the sign of the power only. So let's move on to the next level. Okay, another easier one. So it doesn't require us to use the property. Again, just figure out what 5 to the negative second is, and then 2 to the fourth is, and then I would just grab a calculator and then see what this is, but here is how you do it step by step. So let me see. I'm gonna put that fraction line. 5 to the power of negative 2 equals to 1 over 5 to the power of positive 2. And then in the bottom I have 2 to the fourth, right? That means 16. So this right here, 1 over 5 squared is 1 over 25. Divided by 16, what would that be? Let me see if I can figure that out. 250 plus 150, I think it is 1 over 400. Let me just double check. 25 times 16. Okay, yeah, that's 400. So the answer would be 1 over 400, but for this question I would just grab the calculator and then see what the answer is, instead of taking the risk of making that mistake, because you're already at 81. If you get this wrong, probably you're going to lose over 5 points. So that's all for this video, guys. Thanks for watching, and I will see you in another video.